So let's look at our first query that involves multiple tables. So in this query, I'm joining products to product lines. We're using a table alias here. So we've seen column aliases and how you use the keyword as and put the column alias next to the column name. Here, the table aliases don't involve another keyword, simply the table name, the real table name, space, and then the table alias, T1 for products, and the table alias T2 for product lines. So this table is joined to this table on this condition, and there you see the use of the column aliases here. Product line equals product line. So the rows are going to be matched up. So you imagine in your mind's eye the rows from the products table, all the rows from the products line table. The result is going to be where those rows are matched to the product line. So if the product line doesn't match from products table to the product lines table, that result will not be in the result set. Let's take a quick look at the ER diagram for this, and we'll take a look at this. Products joined to product lines. And you can see there's a formal relationship here. We'll see how this formal relationship, by the way, is made. And this formal relationship is made when the tables are designed. So that's in the script that will create the tables. And we'll look at that in a couple of lectures. We'll look at how that is done. But here we see the product line and the product line, and that's how those rows are joined. So product lines has a one-to-many relationship with products. That is, there's a handful of product lines and then several products that may belong to that product line. So let's say vintage cars. You have many models that can be in the product line vintage cars. One-to-many relationship. The bird foot here, again, the many side. What this allows us to do is have a products table that has only products information here, and a products line table that has product lines information. So we're not going to repeat the product lines information over and over again for every row in the products table. You join it to get that information in your report. So let's take another look at the query now. So product code, product name, those are coming from the product table. The text description comes from the product line table. And then I put T1.product line here to show you that since product line exists in both tables, indeed that's the tie between the two tables, without the T1.product line, then the query would be regarded as ambiguous. Now we know by looking at this that they're always the same in that row. So if you do T2.product line, it's going to be the same as T1.product line given a row. But SQL will regard that as ambiguous if I just had product line here. So I need to use the full table name here, or the full name for this column, which includes the table name, in order to disambiguate it. And in this case, I'm using the table alias here. Putting T2.product line would not change the result. Let's run this query then. So I have my query run there, and you can see product code, product name, text description coming from the product line description, and then the product line here. And you can see all the product lines are going to be that have products are going to show up here. And so our next query, very similar. I put a where clause on it. So where product line contains the word car, using these wildcard characters like this. So anything that has cars, any string car embedded into it, and the product line will come out in the description. So that should filter out planes and ships and trains. So let's run this query here. And we can see that we get the classic cars product line now with nothing else. So the table information, join table information, is usable in all the clauses. It's usable in the aggregate. It's usable in the where clause. All that information now is usable in terms of filtering, but also displaying the information. In this case, giving us a query that only shows information with the product line containing a string car somewhere in it. Notice that I have the join here, so I'm going to change this to inner join, making it really explicit. And that won't change the query because inner is implied. So when you have an inner join here, when we see the outer join, that's going to change this keyword here. It doesn't change it to outer for MySQL. It changes it to something else. But this is the way outer joins are expressed as well. Inner join has many different types of syntaxes. So as you study MySQL, you're going to find tutorials that will show you inner joins with different syntax that I'm using. I'm using the most explicit syntax for inner joins. That is, inner join this table to this table on this condition. There are shorthand ways of expressing the inner join, but I'm not going to show you all the variations. I want to stay with the basic syntax that has the most explicit information, and that's also syntactically most similar to the outer join that we're going to study next. So just keep that in mind when you study inner joins, that you'll see variations on the syntax, and some of those variations depend on how the tables are designed. So they have implied relationships between the tables, so it's not as explicit on the syntax for the select statement. I'll, for the most part, avoid that. There's one thing I want to show you here. So you can use the keyword using here, and that replaces on and this explicit join condition here. So this says as long as the column name is the same in the two tables that we're interested in joining, then you can say using. And again, that's just a shortcut for saying on from this table equals to this table. So that shows you that equal join is very common. It summarizes in the keyword. This is an equal join. Indeed, I hope you can start to understand why greater than, less than are normally not used in inner joins. This is a full-up predicate expression, right? It can express those ideas, but what does it really mean? I can't think of a general purpose. I want to join a product with a product line if the product line is greater in alphabetical order than products. It just doesn't make sense. Most of the time when you do an inner join, and this will simplify the picture in your mind greatly. This confused me for a long time. How to express an inner join in an on condition. It simplified for me greatly once I realized that on condition was almost always an equal join, and other types of conditionals normally not even think about, right? How do I join this to this? By the way, you can join on any column name from products to any column name on products line. This is a formal relationship here. That's how this line is drawn in the tool in MySQL when we generate these diagrams. It comes from the formal relationship that comes from the table design. But you can join on any columns. Most of the time, you're going to join on this formal relationship because that's how the data has been designed to join. It doesn't make any sense to join product vendor to text description in most cases. So in our next example query, we're going to join order details. As we've discussed, order is the main record for the order, containing the basic order information, and then order details are the line numbers that appear on that order. They ordered 3 items. We expect 3 items to appear in the order details, and the order detail lines will describe quantity order and product order for that particular line item on the order table. So they're joined together, and now we're using an aggregate function as well. So all of this join information and all the other things that we've learned about the clause, not just what can appear in the select clause, are in play now with the join. So in this case, we group by order number. So we're going to have a group of order numbers. We joined order number with order detail, and we're going to use group by in conjunction with this aggregate function to see the total for that particular order. So order doesn't have total information. That's good table design, by the way. And for the most part, you don't want to repeat information. So you don't have a sum in your order information for the sum of the order. That sum is calculated by the order details lines. Why is that good table design? Redundant information is considered to be bad in all computer information, because that redundant information, not only do you have to maintain it twice, you can end up with cases where they don't add up. The order, let's suppose order had order total in it. Then the order detail was edited, and a bug allowed the order information itself not to be updated. Right now, you have a sum that doesn't equal to the individual pieces. Right, so you just maintain the individual pieces, and then you sum it up. Good table design, and here we can show how to pull that information together. We have the order number coming from the order table. The status is also coming from the order table, T1, alias here. But the order details has quantity, order, and price each, and that's where the aggregate is coming up here. And you can see here, order number is this, the status of it is shipped, and the total is coming, again, from the order details aggregated. So you can run aggregate function on your joined information. So in our next example, we're going to show join with 3 tables. So we've discussed this, how you can use the join on 2 tables. You can join 3 tables. You can join 4 tables. You can keep joining tables. And it's done 2 at a time, though. Don't think about it as 3 tables being joined all at once. That will confuse you. Think about it as a paired operation. So in this case, again, order with order details and product, where our product information is going to come from. So order number, order date, order line number. So order number and order date come from the order table. Order and line number comes from the order details. Product name comes from the comes from the product table. Quantity order is coming from the order details, and price each also comes from order details. Notice we're not calling out the table names here because they're not ambiguous. These columns exist uniquely in each of the tables that we've joined here. You can put the column names or the table names in front of these, no problem with that. In fact, it might make your query easier to read, but it's not required as long as the column names are unique per the tables we've joined. So again, joining it 2 by 2, and we'll take a look at the enterprise relationship diagram in a second. So orders, interjoined on the order details on the criteria that the order number is the same. Think about that as one operation, and that's the way SQL will deal with it. That's the way SQL deals with it. It says this table joined to this table on this criteria, and it'll do that join operation, and internally within the MySQL server produce a third temporary table that has these results in it. Then that temporary table will be joined on the products table on this criteria to finally form the table that we'll see. So as you do inner join on, etc., each one of those inner joins should be thought of as one join operation, which will produce a third temporary table, which then will be used as input to the next inner join until the inner joins are done. The sorting is done, the aggregate functions are done, and then finally, and a lot of those operations will result in temporary tables that we won't see until the final result set is ready. So SQL sees everything as a table. When all you have is a hammer, then the world is full of nails. And for SQL, everything is tables, including tables that we don't see as a result set that are temporary tables maintained by the server. Let's look at the ER diagram for order, order details, and products. So again, in looking at these formal relationships, the order to order details, it's best to understand this 2 by 2, how the orders relates to order details, and that's again through order number, right? So order, the one-to-many relationship, the parent order table, or the one order umbrella with many order details underneath it. So thus that in turn has a one-to-many relationship with products. One product can appear on multiple order details. How are they tied together? Via the product code here. So that's how we can pull in information from orders to order details to products. Suppose we need product line information. We could join it then with the 4th table, product lines, and then we wanted to tie it with customer information as well. We're making a packing slip, right? We want order. That may be the first thing we bring up in terms of our packing slip. And then order details, the line numbers on the orders. Then we want to include, of course, product information. We also want to have a little bit of product line information on our invoice or our packing slip as well. And, of course, then customer information as well. Who ordered it, what their phone number is, and contact information would also be involved in that one query. And you can see how this is joined one by one. Confusing to me when I first started studying SQL, because I started looking at this whole thing as a big wheel or a big machine all at once. That's not the way to understand it. That's not the way SQL deals with it. It's not the way to understand it. It will just confuse you. Understand these relationships as being 2 by 2. This is joined to this. This is joined to this. This is joined to this. And most of the time, those are going to be equal joins, 99% of the time. The other thing is those equal joins happen table to table. Third table, then is joined to in the next table. Now let's run this query with 3 tables and look at the result set. Oh, order number is ambiguous. Let me fix that. Okay, I fixed my ambiguity again because order details also has order number. Up here, it's considered to be ambiguous. Which one do you want? Now, we know they're always equal, so if I printed it out, it would be equal. But we need to do this ambiguity for the SQL syntax. Orders.order number here. Order date, again, coming from the order information. Order line number, that comes from order details. And then product name, that comes from the products table that we've joined up here. And then quantity, order, price each. You can see how we're getting to be a packing slip here, right? Joining it with customer information, we'll get to some more information that we would also need to put together a packing slip or an invoice here. So from orders, joined on order details on this criteria. Then that result joined to the products table where the product codes are equal. And then put in sorted order by the order number and the order line number. So those are both sorted. So you can see that we have a growing number by order number, but we also see the order line number here. So order date is going to be repeated information because, as well as order number, because these 3 lines are related to the same order. The printed packing slip wouldn't repeat this information, but our SQL query has to in the query window. We have product name, quantity order, price each. All right, next I'm going to add customer information to this same basic query, and we'll print out customer name as well. So we'll get 4th table. Okay, now joining it with the customer information, joining 4 tables, orders, customers, order details, and products. So I added the inner join last here. It doesn't really matter which clause you inner joins or an order, because inner joins, just the way inner joins work, it doesn't matter which way, which order you join them, they'll come out with the same. Now, when you do outer joins, that's not true. Order matters with outer joins, but they don't matter with inner joins. Come out to be the same. So here I have order details, as we saw. That's unchanged from the first version of this query. Order details on orders where the order number matches. Product number on product details where the product code matches. And then customers on orders where the custom number is the same. All equal joins from 4 different tables. And now we can include the customer name in our information as well here. And look at the EER diagram for this. You can see the relationship between orders to customers. One customer can have many orders. So it's possible that one customer can show up more than once here for a different order. Now, notice the information is repeated because this is the same order. So there'd be some work for formatting our actual packing slip. We wouldn't repeat information on that. But this tabular form has no way to express that. So we have the customer number repeated, and there we go, 4 tables. So since all the tables in this database are tied together in some manner, you could really have a query that joins all 1, 2, 3, 4, 5, 6, 8 tables. It's possible. So that could be confusing when you first look at that query. And indeed, if you just glanced at this one, you'd be, wow, what's going on there? Again, understand it 2 at a time. And the entire wheel that gets created would then become more clear to you. So multiple tables with inner join. And next time we'll discuss outer join, also very valuable way to pull together business information for our queries. So outer join next time. Thank you.